In our commercial software engineering degree, with a concentration in design and architecture, we focus on a very simple equation. Professional expertise consists of knowledge and experience. In this sense, the degree is organized into two dimensions. The first is the initial education dimension, where we learn by doing. This includes theory and learning through practical projects. The second is specialization, where we focus on the essentials for software development. Working in teams, applying the right methodologies and techniques. We rely on the principles of modern software engineering to build solutions collaboratively and solve real-life problems. We explore different programming languages and paradigms that help us become skilled developers. This allows us to project a software engineer profile with several important skills.
Problem solving,
Solution design,
teamwork,
development best practices.
and programming.
Jalasoft's proven experience in commercial software development has allowed us to accurately identify the critical skills that define the profile of a modern developer. Following this strategy, there is a degree program based on this profile.
Today, we will talk about the main sagas that make up the degree. A saga is a series of interconnected stories that usually follow a central theme developed over multiple volumes. A very important saga in the degree is the programming saga, covering several related courses. In each course of the saga, we progressively learn new concepts and skills outlined in the profile. Each programming course has the challenge of an individual final project to apply the elements reviewed.
Another important saga is software development, consisting of 6 courses. To illustrate this saga, we use the analogy of music.
The professor teaches the essential principles of music theory and their implementation in group practice. The final assessment is the collective performance of a musical piece. Students, guided by the tutor, apply the knowledge acquired to develop teamwork skills.
While the final project is now a group effort, each student must continue developing personal skills. For example, individual practice to master a language or technique. They also practice with their team. Daily meetings, artifact development, pair code reviews, and more. This helps them improve their teamwork and finally perform their big concert, the group presentation of their project.
In the first course, the goal is to introduce team practices with a simple project. The main objective is to break down a problem into small parts and solve them together.
In SD2, we increase the complexity of the project by considering a modular system. Students take on more responsibilities in the solution.
In SD3, students must learn more tools and mix paradigms. They integrate existing systems. They make technical decisions and also validate and research necessary technologies. In SD4, the type of project changes from classical to rock. We add performance constraints and increase the required complexity to be solved as a team.
In SD5, we consider a more sophisticated project, like jazz, where more elements and concepts must be applied. The team must make decisions about the architecture of the solution, increasing the required complexity.
Finally, in SD6, the project is the equivalent of reinterpreting a piece in another musical style. Students must plan and carry out the migration of an existing system to a different technology.
Throughout these 6 courses in the software development saga, we explore and practice several important concepts for professional and collaborative software development, also covering various fundamental technological tools.
The software architecture saga, divided into 4 courses, allows us to explore the most representative aspects of conceptualization, design, and the adoption of software architecture in our solutions.
This is the degree's main area of concentration. In the first course, we review the main concepts of software architecture, the role, notation, and more. In the second course, we focus on design principles, considering modularity, scalability, and system performance, among other aspects.
In the third course, we explore how software architecture can solve integration and interoperability problems between systems. In the fourth course, the last of this saga, we review software architecture in cloud environments and related methodologies.
Through these sagas, we aim to develop and strengthen the skills defined in the software engineer profile outlined for this degree.
Now, let's look at some updates.
The university is committed to preparing students for the evolving software industry, continuously adapting its educational strategies. A very important element of this evolution is artificial intelligence.
Given its importance in the software industry, the degree includes a specific saga to explore AI with 2 courses: Introduction to Data Science and Machine Learning, and Introduction to Deep Learning and Generative AI.
These courses offer essential theoretical knowledge, combined with practical experience. The initial course lays the foundation in data analysis and classical machine learning techniques. The advanced course dives deeper into mastering modern deep learning models and generative AI.
In addition to these courses, the university implements an AI-driven philosophy, progressively exposing students to 3 levels of AI interaction. In the first 2 years, augmented intelligence, collaboration between students and AI through our Valise agents to understand concepts and how to approach problems. In the 3rd year, automation. AI completes tasks following clear instructions given by students. In the 4th year, autonomous AI agents. AI executes tasks on its own with student supervision.
With this gradual approach to AI, our graduates will become developers who master the effective, efficient, ethical, and safe use of AI, boosting their productivity and that of their teams.